Hello, my name is Burak.
Altay.
My name is Aykut.
Our experiment is Electrophorus and Induction.
Let's introduce our equipment.
To do this experiment, we need a foam plate and a paper cup. We also need an aluminum plate and a pulp.
We have a bulb and PVC band and foam plate.
Also, we have a aluminum plate like this, and we have a paper cup, and we have a wipe.
Let's do the experiment.
Now let us see what happens in this experiment. We had a styrofoam plate, which is an insulator, and we rubbed it with a piece of cloth, and this transfers electrons to back of this plate here. After that, we bring the electrophorus on the styrofoam plate like this, and remember that since the styrofoam plate is an insulator, these electrons, the negative charges, cannot move on the styrofoam plate. So when we bring that electrophorus on the styrofoam plate, the positive ions, the positive charges of the electrophorus, will move bottom of the electrophorus of aluminum plate, and the negative charges of the electrophorus will move top of the electrophorus, the aluminum plate. And then it creates positive ions at the bottom and the negative ions at the top of the electrophorus. So at this stage, if you bring an object or your finger, for example, your finger, to close to this electrophorus, the aluminum plate, the negative charges of the electrophorus here will move towards to your finger to the ground. And this transfer of the electrons will cause a shock in your finger. So if you remove the electrophorus from the styrofoam plate, remember that styrofoam plate was an insulator, so these electrons, the negative charges on the styrofoam plate, cannot move. So these electrons, if you remove the electrophorus from the styrofoam plate, the electrons of the styrofoam plate will be remained on the styrofoam plate. So if you remove the styrofoam plate, electrophorus, so if you remove the electrophorus from the styrofoam plate, the positive charges of the electrophorus will be evenly distributed through the electrophorus. So we have a net positive charge here on the electrophorus, on the aluminum plate. So in this stage, if you bring an object close to electrophorus, for example your finger again, like this. This is your finger, and the negative charges, the electrons on your finger, will move towards the electrophorus. and this transfer of the electrons will cause a shock on your finger again. And this transfer of the electrons brings this electrophorus back to some sort of a neutral state, and that will cause the second shock on your finger. So when we bring the fluorescent bulb to close to electrophorus here in this first part, the flow of the negative charges, the flow of the electricity will light the bulb up. That will cause the bulb to light up in this first part. And when we remove the electrophorus and we bring the bulb again, the negative charges will remove from the bulb to electrophorus, and that will cause the second shock, and that will cause the bulb light up again in the second part. So the reason of this is whenever you have a flow of charges, flow of electricity, you will get the bulb light up. So before we end this video, this whole issue was because of charging induction. It was because of charging induction. And so in this first part, to generalize, in this first part, the negative charges on the electrophorus will move from the electrophorus to your finger or to bulb, and that will cause a shock, and that will cause the bulb light up. So in this second part, the negative charges, the electrons on your finger on the bulb will move through the electrophorus, and that will cause the second shock. And if you bring a bulb close to that electrophorus, the bulb will light up again. Thank you for watching.